This is an exercise for you to try. Let us try to reduce this rational expression to its simplest form. Okay, hoping that you have made your attempts. Now let's look at the solution that I have to propose. We are given the rational expression x cubed plus a squared x cubed y, all of that divided by x to the 6 minus a to the 4 y squared x to the 6. Now, looking at the numerator, we see that x cubed is common. We're going to factorize that out. At the denominator, x to the 6 is common. We're also going to factorize that out. So at the numerator, x cubed is common. When we factorize it out, we have x cubed into 1 plus a squared y. At the denominator, x to the 6 is common. We factorize it out. We're going to have x to the 6 into 1 minus a to the 4y squared. Okay, at this level, what we have here at the denominator, what we have in parentheses is actually a difference of two squares. We should be able to see that, because if you are not able to see that, then the process will probably stop at this level, but it's not yet in its very, very simplified form. So let's demonstrate that it's actually a difference of two squares. 1 minus a to the 4y squared is the same as 1 minus a squared y, all of that squared. Okay, from the laws of indices, a squared squared is a to the power 4, and y squared, that's it there. So, but 1 can also be written as 1 squared, so that we actually see a difference of two squares here. There is this square minus this other square, hence a difference of two squares. Remember again the identity of difference of squares. The identity says, it says this, for the difference of two squares. So let's transform this using that identity. Hence, 1 square minus a square y, all of that square. If we follow this identity, your 1 will be a and your b will be a squared y. So we're going to have 1 minus a square y into 1 plus a square y. So this difference of squares is also transformed to this. Now let's use this transform nature of this and replace this with it, and see if we can proceed with our reduction process. So this becomes x cubed into 1 plus a squared y, all of that divided by x to the 6 into 1. Now we're transforming it, 1 minus a squared y into 1 plus a squared y. All right, we see that 1 plus a squared y is also at the numerator. So that factor cancels out that factor, giving us x cubed all over x to the 6 into 1 minus a squared y. This is not in the simplest form already. We have x cubed up and x to the 6. Remember, when dividing index expressions that have the same base, we simply subtract the powers. So it becomes x to the power 3 minus 6, which is x to the negative 3. And by the laws of indices, it is 1 all over x cubed. Okay, so let's now transform x to the 3 divided by x to the 6 by writing just that. So this expression further simplifies this to, now it is 1 at the numerator, this 1. Now x cubed is at the denominator, so we write it there. multiply to 1 minus a squared y. Okay, now at this point we have the simplified form, or it is in the simplest form, that original rational expression.